Hey everyone, and welcome to a new video on this channel. This time it's about Azure Container Apps, a relatively new offering, still in preview, that allows you to create microservices without having to think about Kubernetes. So no need to deploy Kubernetes, configure Kubernetes, make sure it's up to date and whatnot. Of course, Kubernetes is used under the hood, but you don't need to worry about that. Let Microsoft handle all that stuff. Now we're going to delve straight in and we're going to take a look at building a, let's say, simple application that consists of a front end and a back end. Now, what you have to have first to run your containers with Azure Container Apps is what is called an Azure Container Apps environment. That makes sure that Microsoft can create the underlying infrastructure for you to run your containers in. So you first need that. There are only a few locations today in the Azure cloud where you can create such an environment. Mine will be created in North Europe. A container apps environment also need a log analytics workspace for container logging. In a moment, I'll show you what that looks like. From the moment we have our container apps environment, we can start creating container apps in them. A container app will typically consist of one application container that you have developed. And of course, you have created an image for that. You store that image somewhere, Docker Hub or some other kind of registry. And then you tell Azure Container Apps to run that image for you. In this case, we have a front-end container called front, and we have a back-end container called back. I think it's obvious here, the front end will call the backend container within this container apps environment. Now you also see these revisions here. Revisions are basically versions of your container. So every time you have a new version of your container, of your application, you can have a different revision. We will not focus on that in this video, but we'll take a look at revisions in later videos. So for now, we only have one revision. Now, we just don't run our container like that. We run our container with Dapr support enabled. Dapr is a distributed application framework that you can just enable when you deploy your application. And Dapr allows us to do all kinds of things, like, for example, invoking remote methods in other containers, or even saving state to, in this case, another Azure component, which is Cosmos DB. This is just two examples of what you can do with Dapr. There is much more that you can do. And of course, containers, we can give them a public IP address and a public name as well that resolves to that IP address. Microsoft, of course, deploys your container apps environment automatically with such an IP. And it also gives you a domain name that then all your apps will use. In my case, only one app has an external name, the front-end application called front. So I get front dot and something else. That something else was generated by Microsoft. And we get automatic HTTPS as well. So we publish our application on port 443, all fine. Now, let's get started and let's take a look at what this container apps environment looks like. Creating a container app environment is not very interesting, so there's a link to a gist in the description of this video that contains the command to create such an environment. I created the environment in North Europe and I called it, not very imaginative, my-env. When I click on this, there's not that much to see really. I can see the number of container apps I have running in this environment. And again, think about the fact that there's some form of Kubernetes behind this environment, but you don't see it. And I can see the details of the container apps within this list over here. So I have my front end and I have my backend container. I also briefly mentioned the revisions. The revisions and their names can also be seen over there. You can go to the details of these container apps by just clicking on, for example, the front container, and then you'll get a little bit more information. Now, more about that later. Now, although there is not that much to see in the container apps environment, and let me just go back to it, you can, however, get some more information when you go to overview and then look in the JSON view. In the JSON view, you clearly see the static IP address that the environment was provisioned with, and also the fact that this environment has received a default domain. When I publish my containers, they'll get something like in, for example, front.ashirock and something, etc. Of course, this was generated by Microsoft randomly, and this is of course a link to the location and then the Azure Container Apps.io domain. What we also need is a linked log analytics workspace. During the creation, you have to take care of that. You will see in the configuration indeed here that there is a workspace linked, in this case with this customer ID. Now, what is in this workspace? Well, let's take a look. Let's go to the resource group again. And here I have my workspace, which is LAACA. When I click on this and go to logs, you will see that there's a custom table here. And the custom table or the custom log is a table called Container App Console Logs _CL. I can double click on that and then run the query. And indeed, these are all the container logs from everything that's written to the console of those containers. So whenever you write to standard out or to standard er, you will indeed see that they end up here in this list. With the Container Apps environment provisioned, we can start focusing on the application. The application consists of a front end and a backend. Now they are both APIs. There is no web UI or something like that. So there's an API here, front. Well, it implements a call endpoint. And when we hit that call endpoint with the correct JSON payload here, we can basically instruct the code that implements the endpoint to call a remote method on some other container. So in this case, we'll instruct this endpoint over here to call the save state endpoint on the back container. The save state endpoint will save some state into Cosmos DB. Now, what data will actually be saved? Well, the data is in the payload field here, in the original JSON payload that we have sent to the front-end application. Now, as you can see here, we're using Dapr a few times. So to do the actual remote invocation or call of a remote endpoint save state on the backend container, all sorts of things need to happen. For example, we need to know where does this backend container live? What's the IP address of this backend container? How do I exactly call that endpoint? How do I maybe do retries when something doesn't work when I call the endpoint? Well, that's something that Dapr can take care of. So we'll discuss this more in detail later, but there's a Dapr invoke API that is used to call remote endpoints. We also use the Dapr save state or the Dapr state APIs to save state to a state store. In this case, the state store is Cosmos DB, but there are multiple different state stores supported. Cosmos DB is just one of them. Okay, that's the entire application. Let's focus first a little bit on what Dapr can do, and then we'll deploy the front-end application. From the previous diagram, you know that we use Dapr with the containers. Now, using Dapr with container apps is entirely optional. You don't have to use it. Now, Dapr is basically a toolbox that allows you to do all sorts of things that are very useful with distributed applications. Now, when you do select to enable Dapr on your application, what happens is the following. Suppose I deploy my front-end application, right? So I called it front. That's just a container running in Container Apps. And I ask to enable Dapr. I will get another container called a sidecar next to my application container, my front-end container. Both containers can talk to each other over localhost. And the Dapr sidecar basically allows you to use HTTP or gRPC to talk to it. So if I want to talk to the Dapr sidecar from my application, the only thing I have to do is invoke some HTTP method on it, right? Or call some kind of endpoint. So in this case, for example, you see I'm doing a post to localhost 3500 from my application. Well, then I'm basically talking to the Dapr sidecar because it listens on port 3500. In this case, we're using the invoke API. And what it says here is basically, I want to call the method called saveState. That's just an HTTP method that you implement in code, right? And I want to call that method on a Dapr application with the ID back. So from this, it's clear that when you enable Dapr on your containers, you will have to give a specific Dapr identifier to those containers. And that allows these containers to find each other on the network and eventually, in this case, call a remote method. That's the invoke API. You'll see this in action in a moment. The front-end application uses the invoke API to call the saveState method on the backend application. Now, the actual saving of state is done with a state API. Now, to use the state API of Dapr, it's a simple call to localhost 3500 v1.0 state. And in this case, we want to use the state store that we identified with Cosmos. And we want to, in this case, retrieve a key. So we don't save a key value pair here. We want to retrieve the value which is attached to this key. Now, of course, it's clear that you will have to do something to configure Dapr to know what is this Cosmos thing? How do I reach it? How do I connect to it securely and so on? That's something I'll talk about in more detail later. Now, these are two very useful APIs within Dapr, but there are other ones as well. For example, there's a PubSub API as well to publish messages to a topic. In this case, you publish a message to a topic called orders to a PubSub broker that you identified with the name shipping. And again, of course, you'll have to configure some kind of PubSub broker configuration with the address of it and authentication details and so on. And there's more if you want to, for example, work with secrets from in your application. For example, my front-end application requires a secret from Key Vault. Well, if everything is configured correctly, it could do a simple call to this secrets API and then retrieve a, let's say, a key or something else from Key Vault using a simple HTTP GET. That's basically what Dapr is all about. Now, we won't focus on all of these, let's say, building blocks. We call them building blocks. We'll just use the invoke API to call from the front end to call a method on the backend. And the backend will use the state API to save some state, to save some data in Cosmos DB. We don't take a look at the other APIs. Okay, that's Dapr in a nutshell. Let's continue. Before we deploy the front-end application, it might be useful to know the code it is using. Well, the code it is using is all here in Gbake Super API on GitHub. It's written in Go, and the call endpoint that we'll hit with curl later is in the caller.go file. And the method that implements, or the function that implements the functionality, is the call method function. A lot of stuff here you don't have to focus on, a lot of error checking and of course extracting the information from the payload. But once we have done that, the call to the backend application is done with this simple line over here. Now, we are not using the HTTP APIs of Dapr with the HTTP packages, for example, of Go. No, we're using the SDK in this case, or the software development kit. Dapr has several software development kits for several different languages, and this is the one for Go. You basically get a Dapr client with all sorts of interesting or useful methods that you then can call. There's an invoke method and so on. But in our case, you want to do an invoke method with custom content. I want to invoke a method on a remote container that uses Dapr, and I want to send some JSON as well, some custom content as well. So this invoke method with custom content function or method takes a couple of different parameters. For example, the app ID, that will be back. I want to call a method on the backend container. The name of the method I want to call, that will be saveState. The actual HTTP method, do I want a post or a get? In this case, I want to do a post. Then the content type of the content that you're sending along. In this case, that's in the JSON map variable, which basically extracts the payload field from the original payload that we sent to this endpoint. So all we need to do this remote invocation call with Dapr is simply use this line over here. Now you might think, yeah, what's the advantage of using this? Well, one of the advantages, of course, that automatically it will find the location on the network where the app ID, back in this case, that will send where is that container that we need to contact. And also when, for example, the backend container is not responding, that some automatic retries will be implemented by the Dapr client. And there is much more functionality available as well, but I'm not going to go into that now in more detail. So that's what the front-end application basically does. Finally, it's time to deploy this front-end container. Let's do that. I already went ahead and created the front-end container app beforehand. Now I'm using the Azure CLI here, and as container app create, do know that you have to install some prerequisites, add some extensions and whatnot to make this work. It's all in the gist in the description of this video. You give, of course, your container app a name, you give it a resource group, and you decide in what container app environment you want to run. The code you've seen earlier, the Go code, is all nicely packaged up into this container on GitHub Container Registry. I allow the container to scale to 0, so basically there will be nothing running if there are no requests, and the maximum number of instances is 5 in this case. Because I'm using the Dapr Invoke API, I need to ensure that Dapr is enabled. This gives me the Dapr sidecar. So the invoke with custom content method on the Dapr client I've shown you earlier can then function. Now, because we enable our application with Dapr, we also need to specify a Dapr ID. Now, that's all for Dapr, but this application, the front end, I want to publish it on the internet. So I'm saying Ingress is external. Automatically, that will give me a name for me to connect to that front end. Now, because the name actually, the proxy that we're using actually is using port 443, it needs to know to what real port it needs to translate this request. So my container, this super 1.05, is running port 8080 by default. And that's why the target port is set to 8080. When the container app is deployed, after it's finished, you'll get information about this container app. And of course, I can see here already the fully qualified domain name that I can use to hit that container app with curl, for instance. I will see in a moment how to do that. If I scroll down a bit, I can see some revision informations. And by the way, revisions get a fully qualified domain name as well. So you can work with multiple revisions and try out and do tests to see if they work properly. And I see here my container has been deployed. These are all the properties of the container, the image of the container, and also the resources. I didn't specify resources, but by default you get half a CPU and 1 GB of memory. There's my Dapr ID here, which is called front, and Dapr has been enabled. Great, that's it. The front-end application is now deployed. After creation, the front-end container app is now available in the portal. We can click on it and we can see some useful information such as what's the application URL, what's the container app environment, and where are the logs stored of this container. For the rest, in this container, there's not that much configured. We only have this ingress setting, we have it enabled, and indeed it's accepting traffic from anywhere on port 443. With a certificate as well provisioned by Microsoft automatically. This port, of course, is the internal port, the target port, the port our application is listening on. So my Go app is listening on port 8080. To see the logs of the container, you can click on logs, but then of course you'll be forwarded to the queries over here in Log Analytics. This is great for people that of course know Log Analytics and they know exactly what table to go to and they know how to write these queries easily and so on. I would have liked a more user-friendly log viewer specific for these kinds of console logs. And then the option to go to Log Analytics to do your, let's say, deep dive querying of the logs. Maybe for later, but for now, you'll have to use the Log Analytics features here. All right, now it's time to deploy the backend container. And the backend container implements a save state endpoint to save key value pairs to Cosmos DB. Now, the save state endpoint is actually implemented with this save state function here, where again we check what kind of method you're using, we're reading the body, we're parsing the JSON payload, and so on, and so on, and so on. But in the end, we save some data to Cosmos DB. And we basically do that with this one line of code here. This is again the Dapr SDK and the Dapr client in action. It has a save state method. And there I just specify, hey, what's the state store, what's the key, and what's the value. And in my case, the value is just in this state.data variable, basically. So that's it. This means that this same line of code that you see here will work with any supported state store, whether it is Cosmos DB or something else. Now, the state store name will be required here as a parameter. So I have to find a way to first of all define the state store, give that state store a name, and pass that state store to my code as well. We'll see in a moment how that works. Before we create our backend container, we need to define that state store, right? And you do that by creating a component and a component YAML file. In this case, it's a component YAML for Cosmos DB. As always, you have to give this component a name. So I've chosen to give it the name Cosmos. The type of component is state.azure.cosmosdb. In the Dapr documentation, you'll of course find a list of all the supported state stores and all the names you have to use there. Now, every different type of state store has its own metadata. In this case, of course, it's Cosmos DB, so we need a URL to find, to address our Cosmos DB instance. We also need a key to properly access or authenticate to Cosmos DB. And in this case, as you can see here, it's not just a name value pair like with URL, it's name and secret ref. So we refer to a container apps secret. So we have to make sure that we create a secret called Cosmos key in container apps and then have our Cosmos DB key in that secret. For the rest, we just specify the Cosmos DB database and the Cosmos DB collection. We'll need to reference this file when we create our container app using the Azure CLI, and we're going to do that now. And now we can create the actual backend container. So we just use as container app create again. We give it the name, we have our resource group, we have our environment. We use the same image as before, we just call a different endpoint on that image. We don't want to scale to 0, we always want to have one replica running at all times. And of course, we enable Dapr. Now, because the front-end container is calling a method on our backend container or an endpoint on our backend container, Dapr needs to know how to call the save state endpoint on our container. And of course, it will go to localhost 8080, or it needs to go there. That's why we introduced this new parameter here, Dapr app port, to inform Dapr that when it needs to execute that save state endpoint or call that save state endpoint, it knows what port to use on localhost. Now, the Dapr ID, of course, is important because my front-end application will use this ID to invoke or to call that save state endpoint. Now, this application writes to Cosmos DB, and I've just shown you the Cosmos DB component that you can create in YAML. We refer to that YAML file, the one here, with the new parameter called Dapr components. But because this component file refers to a secret called Cosmos key, we also define that secret with the secrets parameter, and we set Cosmos key to the Cosmos DB secret. Now, there's one other issue as well. My application needs to know the name of the Cosmos DB component. The name is specified inside Cosmos component.yaml. I called it Cosmos. Now, luckily, my application, my Go app, can be configured with an environment variable called state store that will use do the actual save state to Cosmos DB from the Dapr SDK. Now, one last thing, we don't want to have external traffic on this, so we have Ingress internal, but we still specify the port 8080 for this to work. So this creates our container app. It gets a fully qualified domain name anyway, but it's back internal in this case. And if I go down a bit, you'll see as well that my container has this environment variable, state store, with a value of Cosmos. And if I go back a little bit more below, you see that now Dapr is enabled. There's a Dapr ID called back, but the component is also here. We can clearly see it's a Cosmos DB component with the name of Cosmos. So that's why my code needs that name. And the metadata is all listed here with the secret reference to Cosmos key. So that's it. Our backend application, our backend container is now created. Let's check it out in the portal. Here's the container app in the portal, and yeah, just with the front container app, there's not that much to see here. The difference, of course, is that we also configured a secret called Cosmos key, and that's of course at the container app level that this secret is saved. I can see the secret key here, and the value, I can even click to show the value of that secret. For Ingress, we clearly can see it's now internal only for Ingress visibility. Now you might wonder, where is the Dapr information? Well, the Dapr information is kept at the revision level. So if you go to revision management and then click on the revision, and in my case, I only have one revision because I only did one deployment, I can click on the revision, and there I indeed see the Dapr information. So I can see that Dapr is enabled, but also the components that are used. You can have more than one component in use by Dapr. I can click on this component and I can see the component information, 3 manual entries that were in the file as clear text, and then the reference to the Cosmos key secret for the Cosmos DB master key. So everything is there in the portal. Let's now find out if we can use curl to call the front end and eventually save some state using the backend in Cosmos DB. Let's now call our front-end application to call that save state method on the backend application. So if you remember from the diagram, we just need to do a post to the /call endpoint, and the /call endpoint takes a payload JSON with an app ID. Yeah, indeed, in this case, back. The method I want to call from the back container, that's a save state method. We want to post to this save state method. And what do we want to post to that save state method? Well, the payload that's in here. So this is on its own a string, but the string contains a JSON payload as well. It contains key Yahoo10 and then the data 1, 2, 3. So basically, that what should give us a item in Cosmos DB that, well, contains that value. So let's see if this works. Well, this takes a while already because, of course, my container had scaled to 0. So there's some warm-up time here before it returns from this call. Now, I didn't specify -v or something like that, so you won't see any output from this curl command. So we will just verify if that value pair, as key value pair, was saved. We hope this is good. Let's now go and check Cosmos DB. And here we are in Cosmos DB in the Data Explorer. What we'll see here is indeed that there is a document with an ID of back, which apparently refers to our Dapr ID of our backend container. And then, of course, you have these pipe characters here, and then the actual key that we wanted to use, which is the Yahoo10. That was the key name that we used in the curl command. Well, the value is not really 1, 2, 3, because Dapr here is actually base64 encoding the value. There's a specific reason for that we don't need to go into right now. So we see that our front-end application, the call to the front end, and then calling the backend, and then the backend saving state in Cosmos DB is properly working. Maybe an important thing to state here is that when you deploy Cosmos DB here, I've set the default consistency to strong. That's not because it's required by Dapr, it's because I didn't configure it to be able to use, for example, session state or session level consistency. And so by default, when you don't do anything else in your code, strong consistency is required. And then of course, that needs to be enabled at the Cosmos DB level. Now, in the gist, where we deploy the Cosmos DB database, you'll also see that it will use strong as the default consistency level. Okay, that's it. So we now deployed our front-end and back-end application, and we were able to demonstrate how you can use Azure Container Apps, have a multi-container application, use Dapr in the process as well. And we've seen a bit about, for example, secrets handling and Dapr components and setting environment variables and whatnot for your application. I hope you enjoy this and see you some other time. Thank you. Bye-bye.